Welcome back everybody. I hope you've all stayed safe and well during the Easter holiday and the period just before Easter. Now there are a number of you who have not yet submitted work from before the holidays. Can you please make sure you do that? There are some people who haven't even completed the first piece of work. I have asked your tutors to contact you and they have made contact, but you have not yet responded. So can you please make sure you submit the work? It may be a case of you've done it, you've just forgotten to click submit. That's fine, but get it done please and get the feedback on it. Now obviously we're not going to be able to do the practical work that I'd hoped we'd be able to do after Easter, so you're going to have to put up with my dulcet tones during this video. The main part of the course that we've got left to do is to do with the conservation of mass, which we're going to cover today, and types of chemical reaction. The types of chemical reaction, if you do nothing more than do the drag and drop exercise on my website, types of reaction, and do it, copy and paste it into your book, then that would be absolutely fine. That will cover what you need to know. But in this video we're going to focus on conservation of mass. There are two key terms you need to remember before we start. There are reactants. These are the substances on the left hand side of any chemical equation, and the products. These are the things that are formed and are shown on the right hand side of the arrow of any chemical equation. Okay, what I want you to do is think about this little problem. Please pause the video and have a think about the answer to the question, and then have a look at the statements, see if they help you. So pause the video now please. Now the answer is that 10 grams of copper hydroxide and sodium sulfate solution will be formed. You don't have a clue about this chemical reaction, you've never come across it before, but you can use the law of conservation of mass to help you. The law of conservation of mass basically says that the mass of the reactants and the mass of the products must be exactly the same. You cannot create or destroy matter. What happens during a chemical reaction is that the atoms are not created or destroyed, they are just arranged differently. You've got exactly the same number on the reactant side as you have on the product side, and that's the basis of a balanced chemical equation. So the correct statement there is statement B. The products and reactants will have exactly the same mass as they contain the same number of atoms. They're just arranged differently. So again, a couple of things for you to pause the video and think about. What happens to the mass of iron when it rusts? And then what will happen to the mass of the flask during the reaction shown? You might need to be reminded that marble chips are calcium carbonate. So again, pause the video and have a think about what's going on in those two examples. So what does happen to the mass of iron when it rusts? Well, the mass of iron increases. Now that may seem against the law of conservation of mass, but it increases because it's reacting with oxygen from the air, and when we originally weigh the iron we don't take into account the mass of any of the oxygen that's in the air around it. So there's an apparent gain in mass when iron rusts. There isn't really, because although it's a tiny amount, the amount of oxygen in the air will have gone down. Now in the second example, the mass of the flask will decrease. Now again, that may seem against the law of conservation of mass, but it isn't. What's happening is carbon dioxide is given off during this reaction. Remember, acid plus carbonate gives salt plus water plus carbon dioxide. The carbon dioxide is escaping out through the cotton wool in the flask. Now if we were to collect that carbon dioxide and weigh it, and add that into the mass of everything else, we would find we had exactly the same mass. So it's not contravening the law of conservation of mass. So, again, something for you to have a think about. There's several questions here. Try to explain why the mass of these reactions may appear to change. You've got magnesium plus oxygen and then heating copper carbonate. Try and write balance symbol equations for those reactions. And then a couple of little questions for you to think about. So again, pause the video and just spend some time working out the answers to those questions, and then I will go through them with you. So in the first example, when magnesium reacts with oxygen to form magnesium oxide, there is an apparent gain in mass. Okay, that's because the magnesium is taking in oxygen from the air that isn't included if you were to start just by weighing the magnesium. If you have some way of accounting for the oxygen in the first instance, then of course there wouldn't be a change in mass. In the second one, you'd get an apparent decrease in mass because the carbon dioxide would escape as a gas. Now, the balanced symbol equations. You should all know magnesium is Mg, oxygen O2, and magnesium oxide MgO. So starting with those symbols, O2 on the left hand side means you need two oxygens on the right hand side, and the only way to achieve this is by putting a big 2 in front of the magnesium oxide. You cannot change the formula of magnesium oxide from MgO. Once you put that big 2 in front of the magnesium oxide, you then need to put a 2 in front of the magnesium. You've then got 2 magnesiums on the right hand side, 2 on the left hand side. Same with oxygen, 2 on the right, 2 on the left hand side. The next one, copper carbonate is CuCO3, copper oxide is CuO, carbon dioxide, you all know, is CO2. And if you check through those symbols, you'll find no further balancing is required. Now, in a chemical reaction, the total mass of the reactants is 30 grams. What must be the total mass of the products? Well, remember, the law of conservation of mass says that the mass of products equals the mass of the reactants. So the mass of products must be 30 grams as well. Now, if zinc gains in mass when it's heated, going from 26 grams to 32.4 grams, when you heat it in oxygen, burn it in oxygen, to find the mass of oxygen reacted, you just need to subtract 32.4, sorry, the other way around, 26, subtract 26 from 32.4. And the answer therefore is 6.4 grams of oxygen combined with the zinc to form that 32.4 grams of zinc oxide. Now, there's a worksheet attached with this lesson. Please feel free to complete that, hand it in sooner rather than later so you don't forget. And please, as I said at the start of the video, please make sure that you hand in any work that you have not yet submitted.